So it's close enough to a full screen, I think. Raspberry Pi's crime and the CIA Triad. Today we're going to be talking about data backup systems and how they work in a personal setting compared to a more familiar setting that we're used to working with, such as enterprise systems, and how this ties into the core components of a data backup system. And the CIA Triad we're going to get into as well, because that's a banging acronym. So, first of all, who am I and why am I doing this? Two very blunt but important questions, I think. And for myself, I do cloud machine learning operations development during the day, and then by night I moonlight on a part-time job following a clean drinking water project, iArsenic, which I'd love to speak to anyone here about that later if anyone else is interested in clean drinking water. Round-the-clock software nerd, and 2 days out of 365 seems to be my average for speaking. Jack, would you like to introduce yourself?
Yeah, hi, so I'm Jack. I'm also of this project. By day I make apps for students, more specifically to help to kind of enable them to get through university accessibly. And by night I manage communities in my local area. I used to run the LGBT university in my university. LGBT society in my university, sorry. What's on there? And I'm the supposed technical mastermind behind all of this.
Yeah, we're going to put him to the test with a short practical demo earlier, so everyone keep your fingers crossed and pray to whatever software deities you've chosen. So, we're going to be looking at a sort of a real-life case study where we had a real-life data breach that we didn't expect to have, and what considerations we had to make when designing that system and recovering data from that system in a domestic setting. And the domestic setting is really important, because in an enterprise setting, there is a lot of complications that you have to face. Whereas when you're working personally, you can cut a few corners, and it will probably turn out even better if you hadn't cut those corners. That is because of the CIA Triad, which is possibly my favorite acronym in programming, because it sounds, oh, welcome! Are you all here for Raspberry Pi's crime and the CIA Triad? Hey, thanks for coming. We'll take a quick pause while you all filter in. So you haven't missed too much. We've had a quick introduction. We've talked about what we're going to cover. So, yeah, you get to witness that in real time now. So, the CIA Triad, while sounding very hard-hitting and cool, and definitely something to slip into your Zoom meetings if you want to up the sophistication of your prose a little bit, when you strip it back, it is actually extremely boring, because at the end of the day, this is computer security. So we're talking about confidentiality, integrity, and availability. Confidentiality, only the people who should access the data can access the data. Integrity, this just means if you have drive failures or your data over time, it stays the way it should be, it doesn't erode, it doesn't break down, and yeah, things don't fall apart. And availability. So availability basically means everything you've done for your confidentiality doesn't get in the way of being able to access the data in the first place. So, for example, a USB stick would be a great example of something that's got good confidentiality in terms of physical data breaches, there's no internet access or something like that. But if you go to a friend's house and decide to do some nighttime debugging, and you find that you left the USB stick actually at your personal house, well, the availability has just gone so far out the window that you have to go out the door to go get it. So, we know what the CIA Triad is now, and we want our own personal data backup system. What do we need to consider? And the list just goes on and on. Google kind of explodes with all of these terms and concepts that we need to tackle in order to set up a data backup system. So we're thinking about confidentiality. Do we need an auth system? Do we need to have a firewall to make sure only people who can access it do? Do we need multi-factor authentication? We think about integrity. Do we need version control? Do we need backup? Do we need a RAID solution? Do we need encryption? What are the failure points? Could I just do this on cloud storage? Is Bill Gates going to be rifling through my files if I do that? And is Google going to just smash up the subscription fee or take away the the cloud storage solution that I'm using? You never know. And that's why I am a proponent of just taking it all off grid, which is all well and good. until you put your system together and you think like you're on Amazon and you're envisioning this perfect system, and then you come together on a Sunday, get some spare time, you throw it all together, and this is what it looks like for me. We got the high-performance elastic bands, keeping the Raspberry in there. We also have the high-performance, this actually is high-performance, it's 2 separate NVMe SSD 1 terabyte drives going through a USB 3 into the Pi. So you get some of the performance and all of the cost, so that's fantastic. And I kind of had this running along in the background. It was a Sunday project. I really liked it a lot because what I could do is I could work on my personal laptop, and then I could shut it, and in the background all the files would go sync to the Raspberry, and I could open my work laptop, and all those changes would be there, ready to go. But I never really thought about it until one fateful day. So I've decided to call this section the involuntary pen test. It was actually a very well executed physical security attack by one local Portsmouth resident, we assume. And this was something that I didn't think ever really would happen. It's not something that I think anyone tends to prepare for. You think a lot about internet data breaches, switching your SSH port from 22 to 23 so you're less vulnerable to automated attacks, and all that kind of thing. But we had gone off on holiday, and we did make a bit of a fuss when we were going out the door because there's a lot of things to check. Like, for example, is the kitchen light on? I've only checked 9 times to see that it's off, so you've got to go check it again. And all this back and forth, I have been informed, is actually quite a good indication that you've got a very rubbable house for the next couple of weeks. So, introducing our third talk contributor, Mr. Burglar. So, if anyone recognizes this guy, feel free just to let me know. That'd be cool. So, yeah, he basically had all the time in the world to get in, so although everything was locked, they have their ways. And I'll tell you what the most devastating part was. Of the Raspberry Pi and the cardboard box, my personal laptop and my work laptop, he made away with the work laptop, which was insured, and then they fired me. So, so it couldn't really have gone better. What do I do now? I come home. By the way, it took me like, I think 30 minutes to realize I'd been burgled. Despite him doing his best to turn the whole house inside out, I just came back from this trip, we'd done a long drive, I sat down and was like, I don't really remember opening my underwear drawer and throwing it across the room, but I suppose I did. Oh, another thing is that before I left, this laptop that did get stolen, I had this machine learning model I was putting together, and I expected that it would take about 14 days to run, and we were going away for about 10 days. So I set it off, I went away, we did this trip, and then I came back and was like, oh boy, I can't wait to see the progress of my AI machine learning model that's been training for 10 days. I think that's when I realized the laptop wasn't, in fact, not actually running it. But luckily with Syncthing, I could look up all of the files that had been output, and I could see they'd been running for a grand total of 20 minutes, which was not actually that helpful, but it was nice to know, I suppose. So, the scary thing about this was that I'd played with RAID before. I'm not going to try to remember the acronym right now, because I might go wrong. But anyway, what RAID... Yes, perfect. Thanks so much. So, yeah. But an issue I had once was I had that Raspberry in the cardboard box, and it had those 2 disks in it. They were on a RAID 1 system, which just meant that you have 2 terabytes of data, and all the data from one drive is copied over to the other drive. And then one day, for convenience, I tried to pull it out and plug it into my laptop so I could see the files on there. But I got this warning that said that it was unable to show the data on this disk because this disk is part of a larger RAID disk. And I was thinking to myself, like, yeah, I know, that's why I'm trying to recover it off a single disk. Like, let's imagine that disk is in space right now, and I need to access this data. Now, I've been told that it's actually quite a simple process, but because this data was obviously, like, really important, I wasn't able to really experiment and figure it out. It seemed much safer and more secure to just keep it working like it is and not touch it. So one of the things I really appreciated about Syncthing was that the data recovery system or process was just there and ready to go, because all of the files are copied across every device that uses it. So I'm getting a little bit ahead of myself now. I should be explaining what Syncthing is before I explain what it did. And it is, according to their website, a continuous file synchronization program. What this basically means is that if you have a Raspberry Pi running, like the cardboard box one we saw earlier, and you have your laptop and they both have Syncthing nodes on, then in real time, when you make additions to a file, they will get copied over to other Syncthing nodes. So you can fill in a lot of the requirements of the CIA Triad quite simply. I think the process is quite straightforward. And if one of those devices goes away, missing, broken, stolen, anything, the files are just there in their plain form within your Syncthing node. So for me, this was really a simple and effective answer that isn't readily available on Google. I feel a little bit like Google wants you to go down all of these rabbit holes and all of these corners of everything you could possibly expect to imagine with backup systems. And there is a time and a place for that. If you're doing this kind of thing at work or in an enterprise setting, all of those tools exist for a reason. But in a personal setting, what really matters, I think, can be achieved with one Sunday afternoon, a Raspberry Pi. Probably don't need NVMEs going through USB 3, but some kind of storage medium. And another node on your computer. The point of this talk is to really say that that really, really did the trick for me, and I rely on it all the time now. I want to get more Syncthing nodes, like hundreds. I could survive in a nuclear apocalypse and keep working from home. So this is basically a diagram of how I rely on things now. We have the Raspberry Pi. It's plugged into a router, plugged into a power outlet, and then my laptop and desktop, which I switched between as I'm working on different things. And it really feels seamless, because when you boot your desktop up after the laptop's been shut, there's something like 30 seconds before it's started to copy everything over. And if you're programming, you only need to move over tens of kilobytes of data, maybe hundreds of kilobytes of data, sometimes more, and that does take a little bit of time. But it's not too much to wait for. In practical experience, I would say it's been perfect for me. So to show how perfect it is, it's time to be bold. It's time to do a practical demo. So we're going to switch these two laptops around, and everything's going to be fine. It's totally going to work. Yeah, we didn't actually test it plugged into a monitor, it turns out.
Sorry, you don't need a second mic, I can take it.
Way. Okay.
All right, we did it. What would you like to tell the terminal?
Just write some really cool Python code, and then we can watch it transfer over from one virtual machine to another through the magic of Syncthing, and it's totally going to work as well. So what we have here is we have a virtual machine on the left, which we've labeled laptop demo, and a virtual machine on the right that we've called Raspberry demo. We dreamed so big for this practical demo, and we wanted to set up from scratch. Oi! Thank you. So there's the critical moment. Big round of applause for Jack for getting that all set up and ready. So we wanted to show it starting up, being configured, the nodes. There's a web interface that shows you. We didn't set it up with an error. I don't know where that came from. That could have come from somewhere else. So we wanted to show it all coming together from scratch. While it is extremely simple, and my experience of setting it up feels very easy, it's not that easy for a 20-minute demo. So we've had to strip it down a little bit. But yeah, we're glad that we can show you. As you're working away on your code, you can, without a care in the world, not even a git pull, just have the code syncing over, backing up, and then ready for any other devices which you also have Syncthing installed on. So we're actually a little bit behind time, which is unusual because I'm much better at going way over. But I think that means that we have plenty of time for questions. So that's actually a good thing.
Thank you, Kane and Jack. So, time for questions.
What if you edit both files?
It breaks. You get conflicts, and conflicts are a really interesting thing in programming because there are lots of answers and none of them really work. So they all have areas where they kind of fall apart. So I have tried doing this before where you're sort of like one computer than the other and you're editing two things at once and like watching the changes come over. At some point, it does have a bit of difficulty, and you have to pick the file that you want to keep.
Any issues with large volumes of data? Like, does it, if you add, I don't know, a gig of images or photo files, how does it handle that?
Yeah, that's a really, really good question. So I've also got some full resolution photos that I keep on my laptop that do need to copy over. And it does take time. It's limited by your internet speed, which over a home network, if you have your router and then your laptop that you're working on, and say you're waiting for it all to transfer over to your second computer, it takes a little bit of time. And obviously, the more data you have, the more time it will take. But I find, because of that internet speed, it's actually really quite okay. You have to wait, but it doesn't grind to a halt or anything like that.
Any other questions?
What about the reliability of the module of the Raspberry Pi? Do you recommend a specific implementation / brand of Raspberry Pi to be something that need to be on 24 hours, 7 days a week, or everything can work? Or did you experience problem about the reliability of the Raspberry Pi solution at all?
Yeah, that's a really good question. And something that I think is always a little bit of a battle when you're working with Raspberries is making sure that you make all of the decisions when setting the Raspberry up correctly for what you're working on. The system I use uses Ubuntu, but it does feel like some things are a little bit more tricky than it needs to be using Ubuntu. So I want to set another Raspberry node up basically for fireproofing, because that's what I nerd out about with these kind of data setups. I'm like, what if everything exploded? So I want another node in another building. And I think when I do it again, I'm going to try using Raspberry OS.
More than the operating system, I was concerned about the hardware. The Raspberry Pi hardware. So I know that some of the boards that we have around, those Raspberry Pi are not meant to be on 24 hours, 7 days a week. So do you recommend a specific Raspberry Pi hardware that can be, without a lot of problem, be on 7 days a week, 40 hours day, no, 40 hours, well, 24 hours day, 7 days a week?
In my experience, they're a lot tougher than they would lead you to believe, I find. And I'm more of a drive it until the wheels fall off and then fix the wheels because they'll probably be okay kind of person than a, let's make sure everything's up running how it should be. And the way you make that work is I had obviously 3 Raspberry nodes on here for redundancy. I think if you really want to throw caution to the wind, 4 or 5, you'll be pretty bulletproof. And the thing I have in this setup is I did make sure to get a strong case. You can see the silver element there, that's the Raspberry. And this thing just sheds heat, and it seems quite comfortable to run like that, although it did break the Wi-Fi, so that's something that you need to think about. When you put the Raspberry in a case, the internet just says no. Yeah, yeah, absolutely. Thank you.
I've got lots of questions because I've tried to do this a few years ago and it just didn't work. Do you sync any of your files up to a cloud service or a remote machine as well? Or do you just use physical machines that you use
they have?
So this, for me, has kind of been a way to sync over code changes so I can switch devices really conveniently. That was always the biggest selling point for me. I didn't realize that it was also a very viable data backup system until the time came that I needed to do that. And I kind of never considered that it would be able to do that because of the simplicity of it. So, sorry, could you just remind me what the...
Whether you sync the files up to the cloud or...
Yeah, of course. So when wearing some of my hats, we use Google Drive, and I really like Google Drive. I think it works well, and there's nothing really wrong with it. It works well in a team, and it very well may be a solution that works for you. For me, the concern really is I feel like there's this constant prod to keep an eye on my subscriptions and the state of the technology. There's always more you can do with it, whereas this feels like it's kind of isolated just to my personal file structure. So I really appreciate that about it. It provides a very low cognitive load, I feel.
So, do you need to sort of punch a hole in the firewall, or does it just connect out and then you don't need to do any firewall config?
Oh, that is such a good question, yeah, because it's obviously not totally off-grid unless you are doing that firewall connection and that peer-to-peer setup. Now, what you can see when you go to the browser, the web UI, is that there are, let me just make sure I get this terminology right. There's a discovery panel and a listeners, or a discovery attribute and a listeners attribute. And these are the central Syncthing servers, I believe. I don't know if you can set one up yourself. I would expect, because it's an open source project, that's how you maintain the sort of off-grid nature of it. But this system does rely on those external running servers. And for me, it's not really been an issue. I didn't actually realize that that was how it worked until I was preparing for this talk. But I have to admit that it does mean that's something you have to consider if you want to be truly off-grid. In that case, you would need a peer-to-peer firewall configured setup. And that might be worth it for you. It might not. For me, as much as I would love to be totally off-grid, I personally don't feel the need for that. Did I see a question a little bit further back there, a little bit earlier? No, it's okay, it's no problem.
I have a question then.
Oh, please.
Do you have any plans on further improvements?
Yeah, absolutely. And they mostly stem from if I was to do this again. I think the case could be improved. I think there's some security benefits to having your computer in a shoebox. I think I'll continue to have a flashy work laptop as part of my security system and leave that out. But really, when it comes to the Raspberry itself, I think the biggest issue is the NVMe data solution. I think if I did this again, you'll get much more capacity for the cost if you used hard disks, are what I'm leaning to at the moment. This would be if you really wanted to beef it up past 1 terabyte. I think it starts to make sense. Up to 1 terabyte, I think USB solid-state solutions are pretty okay. You have to watch out that their read-write times are consistent because a lot of them just blow up in heat over 2 or 3 seconds. So, yeah, you do need to shop around a little bit. That's the primary big one. Changing that very bottleneck through USB 3 data storage system, I think, is the biggest weakness.
Cool. Any other questions? Yes.
Thank you. I was wondering, what do conflicts look like? Like you said, you switch between your work and your personal laptop. Do you finish on your work laptop, go over to your personal laptop, and the stuff you're looking for just isn't there, and then you have to go look for what went wrong? Is that those conflicts, are they in the web interface?
Yeah, You see them in the web interface. Generally, I've found it's best to work with it and not sort of push its limitations. And this area is a limitation for it. It takes about 20 seconds minimum for changes to come through, in my sort of anecdotal experience. So the trick really is to only work on one machine at a time. And 99% of the time, I don't check that all the files have synced over before I start making changes, and it's not a problem. But like we say, if code changes, for example, are queued behind large file transfers, then yeah, this issue will crop up. And what I find I usually do is copy it out of the folder that's being covered by Syncthing, so it thinks it's deleted, and then all the nodes can just agree that the file isn't there anymore. There's no conflicts in that case, and then just bring it back in. And I suppose it's not very glamorous. I wish I could say there was a way that it just completely solves this issue, but that's been my way of going about it.
I was going to ask, is there any way of making it so Syncthing like looks only at specific files, like regex or anything like that?
Yeah, absolutely. And I think there's a big problem with this. So if anyone's feeling particularly open sourcey and they want a bug to hunt down, you scope it to a folder. So you say, I would like to share this folder across these nodes. And for me, this is how I have my programming folder and my pictures folder going to different devices, because I don't need the pictures on my work laptop. So when you're syncing code over, you don't want to bring the Vem folders or PyCache or node modules or all that kind of thing. So it has a regex implementation where you type in everything you want it to ignore, and you put that into your work laptop, and then you go work at your desktop, and you pyenv install, Triad, etc., npm install, all of these dependencies that shouldn't be copied over. They'll get copied over to your desktop. And now this is where things get sinister. Because the desktop, if you hadn't configured the same ignore list locally, it won't ignore all of those PyCache folders and all that kind of thing. And then they will get copied over to the computer that should have been ignoring it. So I think what there should be is some kind of centralized Syncthing ignore folder that works probably with the same thing as get ignore. And why they haven't made that, I could not tell you. But I think it's a ripe and ready issue for someone to jump on.
Is it continuously being developed? I just searched online and I know the Android app is discontinued.
Oh, really? Yeah, I tried with the Android app for a little bit. I had like a journal diary on it. And it never really worked. It never really worked very well. I think the issue with Android is that to have continuously running services, Android just loves to shut them down.
Thank you, Kane. Thank you, Jack. That's a gift
Oh,
for you.
Thank you.